Hello again. We're going to move on to Chapter 4-2b, writing decimals as fractions. This first part is review. We have written terminating decimals as a fraction or a mixed number in the past. What's going to be different this year is you're going to be having to put negative signs in at times. First of all, we need to know that the place value farthest to the right will become our denominator to the fraction. The numerator is going to be the digits that are in that decimal, only we're going to forget about the decimal point. Once you have a denominator, you don't need a decimal point. That will form a fraction that we will need to reduce to lowest terms. So let's get started with our examples. Number one, the first thing we do is determine the denominator. The place value farthest to the right is right here. That's a 10. Then it says take the digits, write them in the numerator without the decimal point. Now we need to reduce to lowest terms. These are both have a common factor of 2, so 2/5. Therefore, 0.4 is the fraction 2/5. In number 2, I always tell students when you've got a 2 point something, that means you're going to have a mixed number, like 2 1/2, 2 1/3, 2 5/9, or whatever. So I always tell students, just take the whole number and put it over there, and then just work with the decimal. Now again, here's that decimal part. The 0 is in the tenths, the 6 is in the hundredths. And I write the 6. I can skip the 0, I don't need it, and I do not write the decimal point. Now I look to reduce. My GCF here, again, is going to be 2. If nothing else, try your successive divisions. They're both even numbers, so divide by 2. We will get 3/50. 3 and 50 do not have a common factor. They are relatively prime. So this 3/50 becomes my fraction part of the mixed number. Number 3 is pretty similar, except you need a negative sign, so you hit pause, and then I'll go over it. Again, I would write the -3, and then I would just work with the 9/10. That is in lowest terms. Now, by the way, if you can do that mentally, if you can do this one mentally, go right ahead. All right. In this one, tenths, hundredths, thousandths. And some of you probably got to 625 and said, I quit. That's too bad, because you really don't have to. First of all, you can tell that a 5 would go in there because into both numbers, because the 625 ends in a 5 and the 1000 ends in a 0. So we can go back to the divisibility test. If the denominator is 1000, my first thing is that I always try 125, and then if that doesn't work, I try 25. Then if it doesn't work, I go to 5. If you actually try 125 here, yes, go ahead, use the calculator to take 625 divided by 125. Some of you grabbed it anyway, I know you. Okay, you're going to get a 5/8. And sure enough, 5/8. This is the part that's new, and yep, it can be a little confusing, so follow along with me. We're going to let n represent the decimal. Then we multiply both sides by the power of 10 that we can get from our denominator. Then we subtract. That eliminates the repeating part, and we solve the resulting equation, which will mean absolutely nothing to you until we do an example. Let's look at example 1. 0.4 repeating. We let n equal 0.4. Since our place value here, in other words, this place value is tenths, I will multiply each side by 10 and get 10n equals 4.4. Now I'm going to subtract to eliminate that repeating part. So I bring this part down here and I subtract. This 0.4 and this 0.4 will be a 0, so I'm left with 4. Notice that I now have a one-step multiplication equation. I'm going to divide both sides by 9, and n will equal 4 ninths. So 0.4 repeating is going to equal 4 over 9. Let's try another example. Notice that this time you've got tenths, hundredths. So what I do is say, all right, I'm going to start with 100n right away, and that's going to give me 45.45. Now if you want to go the repeating, you can go the repeating. Then I will let n equal that 0.4 repeating. It's kind of weird, but it's true. A 0.45 repeating minus a 0.45 repeating, that's going to become 0, so I'm left with 45. And 100n take away an n leaves me with 99n. Notice I have a one-step multiplication equation. Divide both sides by 99, and n will equal 45 over 99 that I now have to reduce. I see a 9 in there right away because it's 9 times 5 and 9 times 11. So 5 over 11. Therefore, 0.45 repeating is equal to 5 over 11. If you want to hit pause, go ahead. I will tell you that just like we did in part 1, I work with the 3 right away, and then I just worry about this 0.42 repeating. If you want to try it, hit pause, otherwise I'll go right into the explanation. Since it's 100 tenths hundredths, that means I'm going to have 100n equals 42.42 repeating, minus n, which is my 0.42 repeating. By the way, you really don't have to have the repeating in there, so it's up to you if you want to put it in or not. You'll notice in example 1, I didn't put it in there. If it's easier for you to think of it as not having to repeat, then don't repeat. 99n will equal 42. And sure enough, I've got another one-step equation. Divide both sides by 99. N will equal 42 over 99. Okay, this one's a little tougher, but in all honesty, 4 plus 2 is 6, so that means 3 goes into the 42. And 3 into 42 is going to go 14, and 3 into 99 goes 33. So then I go back up to the top and just add the fraction to the whole number in order to make my mixed number. And that will conclude Lesson 4.2b. Scouting out.